Analytics is Automic Automation's graphical reporting module. It generates reports like pie and bar charts on virtually every aspect of our data. Structurally, it's pretty simple, but it does require a number of installation steps. The deployment of certain components generates configuration files that are required by others, and so we recommend sticking to the suggested sequence of steps. The infrastructure is as follows. There are three main components, seen here in the orange color. The PostgreSQL Datastore for data repository, which we have to deploy. That's the analytics database that stores sampling data extracted from the engine's database for reporting purposes. Then there's the backend, which is the core analytics components. This is a Java web application that's served over embedded Tomcat and is accessible using a REST API. On a technical level, the web app is activated using analytics-backend.jar, which we can incorporate in the Service Manager for interaction and auto start. The backend comes with a log for troubleshooting and two configuration files for connections. The first is the main file, application.properties. This contains connection details to the analytics database and the engine database. The other is ucx-edda.ini, which contains the AE system, host, and port of the engine processes. Finally, we have the Web UI plugin, which we install with the AWI web application. It serves the interface elements. It has one configuration file, plugin.properties, which contains the REST API encryption key for security, and connection details to the analytics database. The procedure has three sections. The first shows how to configure the Datastore. The second shows how to configure the backend, a web application accessible via REST API. It's the central technical component responsible for data exchanges between the various parts of the AA configuration and analytics. In the last, the UI plugin serves the interface components to the web interface. In the first section, we copy the analytics directory from the install package to the instance directory. We install PostgreSQL, the required database system for analytics. We configure the database system so that it's accessible over any type of connection and execute a script to deploy the analytics data structures. In the second section, we configure the backend. We update application.properties so that it can interact with the Datastore and the automation engine database. We copy the JDBC driver to enable data connections. We update ucx-edda.ini so that the backend can talk to the automation engine. And finally, we configure the Service Manager so that analytics auto starts at boot. In the last section, we copy the UI plugin over to Tomcat. We update its plugin properties so that it can talk to the backend over the REST API. The analytics files are included in the installation package, so we copy them over to the Automic Automation directory. Postgres should be installed. Simply follow the instructions. The default superuser is Postgres, and you should set its password. You should check the Automic compatibility matrix, especially when it comes to Postgres. When you're done installing, you can start the system and expand the default Postgres database using pg4admin to make sure everything is working okay. You'll be prompted for that superuser password. PostgreSQL needs to be configured so that it can accept connections from any user and host. The file is found in the data directory of Postgres, which by default is under Program Files. In order to upload the analytics data structures to Postgres, Automic provides a script called setup.psql. The script has to be executed from the analytics Datastore directory using psql, so we cd to it. From the Datastore directory, we execute setup.psql using Postgres' script tool, psql. This is how the script is broken down. We specify the directory where the psql executable is found. We run the psql command. The -h parameter is the host where the database is, -p is the port, which by default is 5432, $U is the superuser, -w means no superuser password, and will be prompted for that password at execution. Then we have the script parameters listed using -v. They are database username, user password, and then the name of the database itself. You should keep the analytics default all in lowercase. -f designates the script we're executing. Before execution, if you're interested, we recommend taking a look at the script to see what it does. This is the superuser password prompt. The first part of the script executes and creates a role and a database. We're prompted for superuser password again. The script creates the rest of the data store. Notice the line Backend API key. The backend is the main technical component of analytics. Securing communications requires an API key, which the script generates dynamically. We'll need this key in the future, so the best way to track the key is to copy the contents of the command window to a text file that we create by right-clicking on the desktop. The contents of the file are irrelevant, but now we have the text string for the API key. We move on to the second section, which is the backend. The backend is a web application. It has a configuration file called application.properties. We update that file to specify the JDBC connection to both the Analytics Datastore and the A database. When running, the backend will pull sampling data from the automation engine, so it can serve it over to the web interface. The file doesn't exist, but we have a sample, so we just copy and rename in order to retain the original. The first fields we have to populate are the data source URL, the user, and the passwords. These were passed when we executed the setup.psql scripts. We specify the JDBC connection to the automation engine database, the database user, and passwords. The first line can be found in the ucsrv.ini file, and the user and password were sets when we created the A database. Here we're working with SQL Server. When we installed the automation engine, we had to download the JDBC driver and place it in the lib directory of the engine's bin directory. All we have to do is grab a copy and place it in a directory called JDBC of the analytics backend. The backend needs to connect to the automation engine. Communications rely on the following data points: the Automic system, the AE host, and the port. So we update a backend file called ucxedda.ini. Finally, we update the service manager, specifically the SMD and SMC files. This allows us to set analytics to start automatically at boot and control the module interactively. The SMD file is the definitions file. It's what creates the functional services. The SMC file is the commands file. It sets the auto start. Remember, the analytics database backend should run on a separate system and have a dedicated service manager. Therefore, the SMD file will be empty. We start with SMD. At the core of the analytics operation, we find a jar file called analytics-backend.jar. Executing this file starts the backend. Parts of the definition are separated by semicolons, but everything should be on a single line. The first part of our definition is define analytics backend. This is an A instruction for the creation of the service. The second part is the Java command from the Java bin directory. We find a number of arguments for things like heap space and recommend sticking to those. Then we have our jar file. The third part is the directory where analytics-backend.jar is executed from. The SMC file contains the auto start and timing instructions. We auto start the Datastore and the analytics backend. We move on to the third section, the UI plugin. This is another jar file that serves the UI elements over the web interface. We copy the plugin from the installation package to the AWI web application directory in Tomcat. The plugin needs to access the backend, and we have a configuration file for this in the config web UI plugin analytics directory called plugin.properties. The first field is the backend API key. This key secures access to the backend's REST API. The key was generated by the setup.psql scripts when we deployed the Datastore. We stored the information in a temporary text file. We copy it. The second field is the backend host. Analytics has been installed and configured. It's been set to auto start in the Service Manager. We start the Service Manager Windows service and see if it works. Analytics is started. We'll know if it works when we physically test it in AWI. Let's go ahead and test it in AWI. You can log in using Client 0. We create a dashboard and an analytics widgets. One of two things will happen. Either you see your bar chart, in which case you're good to go. Even if it says no data, that's still acceptable. Or you'll see a red screen with a series of Java errors. There are problems in the configuration, and you need to figure out what they are. These are the starting points for troubleshooting. If the analytics service doesn't start in Service Manager, the issue might be either with the backend, the database connection, or a JDBC issue. Use the Service Manager log. A backend jar definition not properly populated will inform you that it cannot find the command, or you have an invalid directory, or it can't find Java. If you have a database connection issue, you might see a message about a missing window. The analytics backend log will tell you more. It might indicate a connection refused or a missing Java work process, as an example. In addition, the Postgres PG_log and the Tomcat IA and Tomcat logs will help you find issues with the backend, database, web server, and agents. If the service starts but you get errors in AWI, you're potentially looking at plugin issues linked to plugin.properties.